So we can also use the second derivative test to determine if a critical point is a maximum or minimum. So if you remember, a critical point is when f prime is 0. So a critical point critical point is when our derivative is 0 or does not exist. Now, if you remember, what this means is that you would have a horizontal tangent there. So if your function's going along, a critical point's going to have that horizontal tangent. So it doesn't guarantee that there's a maximum or minimum there, but what it does guarantees that we're going to have a horizontal tangent if the derivative is 0. If it doesn't exist, it's probably a corner or cusp, but that's also a place of interest because that could be a maximum or minimum as well. So that's why we look at these critical points, because that's where more than likely you're going to have your maximum or minimum at. So if we have a critical point, what if we find out that f double prime at that spot is negative? And what that would mean is that we are concave down. So what we have is a horizontal tangent, but with the sad face, right? So our function would be upside down. We would have a critical point there, meaning a horizontal tangent. And since our function's opening down, that would actually mean that this would force that critical point to be a maximum. Similarly, if you were to have it opened up, so let's just say at that particular critical point, that's why I'm putting x0, that's a particular x value. So let's just say it's greater than 0. That would mean that f is now concave up. And then that would mean you have like a smiley face. And so at that critical point, you would have a minimum. What if f double prime is 0, though? So let's just say we have a critical point, but f double prime is 0. It actually equals 0 at that spot. And if you remember, that means that, it could be a point of inflection there. It doesn't necessarily have to be a point of inflection. It could be concave down, and then it changes the concavity, and then it just continues to be concave down. Or it doesn't change concavity there. It just goes from concave down to no concavity to concave down again. So that's a possibility. So that just means we don't really know if it's going to be a maximum or a minimum. So we'll say test fails. And this is actually quite common, because if you know for your typical functions like f, let's just say f of x equals x cubed, then f prime of x would equal 3x squared, so that would make your critical point at x equals 0. And then f double prime of x, though, would be 6x, but then at this particular spot when x is 0, if you plug it in, you get a 0 for your second derivative. So it's actually quite common that this test fails. That's why I'm not a big fan of it. The other tests we learned, first derivative tests, will always work. So for some reason, they want you to know this. And so that's why we're going over it. And it's kind of cool. If you have it concave down, you can picture that maximum. It's one of the few things I remembered from high school calculus, because it was just so memorable. It just made so much sense. Concave up, at that critical point would mean you're at the bottom, a minimum. But the first derivative test is always going to work. So why are we going to use a test that sometimes fails? Beats me. But that's just academics. They want you to know everything that other people have come up with. And so let's do some examples. So we're going to classify these critical points. So the function f of 2 equals 3 doesn't really matter so much. We have a critical point at x equals 2 because the derivative at 2 is 0. And that's because of this right here. So we have a critical point at x equals 2. So this is a positive, so we're concave up, because our second derivative is positive. So we're concave up at that critical point. So that would make that point a minimum. And what are the coordinates of the point? The coordinates of the point are 2, 3. X is 2, y is 3. So 2, 3 is a minimum point because we're concave up. Right, here's similar idea. So at -6, we have a critical point. Here we're concave down because it's negative. So that critical point would be a maximum. And then last, it fails because we don't know the second derivative. I mean, we do know it's 0, but that's not enough information given here that we could figure out the maximum minimum. They didn't actually give us what g is. They're just telling us that the critical point occurs at 7, and that the second derivative at 7, we don't know. It's 0. So, or I keep saying we don't know. It's 0. We know what it is. It's 0. So point is, though, we don't know if it's concave up or concave down. It's neither one. So we know that it's neither concave up or concave down. So it's not going to help us find that maximum or minimum because we need to know for sure is it concave up or concave down.